Dominic Sparrow please come to the main office? Thank you.
So we're going to learn something called completing the square, which you should have just seen in the video that came before this. And now what we're going to look at is how this actually works when you're trying to solve. So if I start by looking at x plus 4 squared, remember that to actually simplify or expand this, we would do x plus 4 times x plus 4. And we would end up getting x squared plus 4x plus 4x plus 16. Now we would simplify that and get x squared plus 8x plus 16. Well, as we do a few more of these, we'll see that there are some relationships that are being established. In this particular expression, the b value is 8 and the c value is 16. Alright, so if we do that for the rest of these, this one would be x squared plus 5x plus 5x plus 25, which would be x squared plus 10x plus 25. The b value is 10, the c value is 25. This would be x squared plus 6x plus 6x plus 36, or x squared plus 12x plus 36. The b value is 12, the c value is 36. Even with fractions, it still works the same way. We would have x squared plus 1/2 x plus 1/2 x plus 1/4, which would be x squared plus 1x plus 1/4. The b value is 1, the c value is 1/4. And this would be x squared minus 7x minus 7x plus 49, x squared minus 14x plus 49. B is negative 14, c is 49. Let's see, x squared minus 10x minus 10x plus 100 is x squared minus 20x plus 100. The b value is negative 20, the c value is 100. So let's see if we notice any of the patterns here. It wants to know what is the relationship between the constant from the factored form. There's the factored form. The constant is just the plain number. So that's the plain number. And the b value in the simplified version. So if you take a look, there's a 4, there's an 8. 5, 10, 6, 12, 1/2, 1, negative 7, negative 14, negative 10, negative 20. And these have actually happened this way every single time we've done it. Hopefully you're recognizing that the b value is always double the constant. And we could also work backwards. That also means that the constant is half the b value. Okay, so now let's see if there's one more thing we can figure out. Alright, let's compare the constant in the factored form to the c value. So again, if you look at these numbers, we've got 4 and 16, 5 and 25, 6 and 36, and so on and so on. Hopefully you realize that, oh look, the c value is always the square of the constant. Okay, so this is information that we're going to use to help us solve equations when they are not factorable. Alright, and you can do it even when the equations are factorable too, but this is a strategy specifically so when you can solve when it's not factorable. if I were to look at something like x squared plus 10x plus 25 equals 9, the old way to do this would be to subtract 9 so that this is equal to 0. Okay? Well, if I subtracted 9, then I would get x squared plus 10x plus 16 equals 0. I would think of numbers that multiply to 16 and add to 10, which would be 8 and 2. So I get x plus 8 times x plus 2 equals 0. Set both of these things equal to 0 and solve so that x is negative 8 and x is negative 2. Okay, so we can do this by factoring, but I do want to show you another strategy. All right, if we think about this first part right here, so if I have x squared plus 10x plus 25 equals 9, I want to look just at this right here, and I want to notice, let's ignore that this is not equal to 0 right now. Does this factor? And hopefully you notice that it does. The two numbers that multiply to 25 that add to 10, well, that would be x plus 5 times x plus 5. And another way to write this is x plus 5 squared. Okay, now, based on what we've done in class the past couple of days, you should know that we can solve this just by doing the square root. So if I were to take and do the square root of both sides, I would get x plus 5 equals positive and negative 3. So I would subtract 5 and get x equals, well, positive 3 minus 5 is negative 2, and negative 3 minus 5 is negative 8, which matches the two answers that we got up here. Okay, this is what it means to complete the square. To complete the square, as you saw in that video, means to make the polynomial be a perfect square trinomial like this. Okay, so what if, I'll show you this when we come back on Monday. What if I were to have a quadratic equation that looks something like this one right here? Okay, the way that we're going to do this is we're going to look at the left side of this. This thing right here, it is factorable, so we could solve it that way, but I also want you to notice this idea of completing the square, because that's our goal. We want one side of the expression to be factored with a repeated factor, meaning perfect square. Okay? There is nothing here that would make this thing a perfect square trinomial. So what I'm going to do is a process where I ask you to figure out what is A, B, and C. Well, we'll do that later actually. Specifically right now, I want to know the B value. Okay, the B value in this case is equal to 14. Now if you notice from the video, we're going to cut that B value in half. So I'm going to do half of B, which in this case is 7. Now, since this process is called completing the square, I'm going to square that number. And 7 squared is equal to 49. So in order to make this trinomial right here be a perfect square, I need that 13 to really be a 39. So what we need to ask ourselves is, what do I do to the 13 to make it become a 49? Well, I think if I was to add 36, 13 plus 36 is 49. I do have to remember that the rules of equations say what I do to one side, I have to do to the other. So this would give me x squared plus 14x plus 49 equals 36. Okay? Now, if you look at that left side, what are the numbers that multiply to 49 that add to 14? Well, that's 7 and 7. So this would be x plus 7 times x plus 7 equals 36. That right there can actually be written as a square, so it would be x plus 7 squared equals 36. And now we have just completed the square. We've made this thing into a perfect square so that we can actually do the square root and solve that way. So this would give me x plus 7 equals positive and negative 6. So we would subtract 7 from both sides, and we would get x equals negative 1 if you do positive 6 minus 7, and then negative 6 minus 7, x would be negative 13. Here are your two answers. Okay, I'll do one more. If we take a look at this, I want to complete the square. The numbers that multiply to 11, negative 11 that add to negative 6, there aren't any. So I'm going to go through this process. The b value is negative 6. Half of the b value is negative 3. Now I'm going to square that number. Negative 3 squared is positive 9. Negative 3 squared is positive 9. So I want that negative 11 to really be a positive 9. We want to make C be 9. Okay? Well, let's see. If I were to add 20 to this, and then I would add 20 to the other side, I would have x squared minus 6x plus 9 equals 1. Okay? Well, that's good because now this factors. It would be x minus 3 times x minus 3 equals 1. This would be written as x minus 3 squared. I would then do the square root of both sides, so I would get x minus 3 equals positive and negative 1. I would solve by adding 3 to both of these terms. So positive 1 plus 3 is 4, negative 1 plus 3 is 2. And there are my two answers. Okay? I would like you to try questions 3 and 4. See if you can make that work, and I will see you in class. I hope you have had a fantastic week off.